don't have any assignments 4 weeks from now. Yeah. So we could this week, next week, and next week. Yeah, so we could have, about a month from today, maybe, for the maths assignment. I think that's more than enough time. I usually give people 2 weeks to do it. So, 4 weeks should be more than enough. Like I said, you can also talk to Donal and Mark about it too. You still have the paper I gave you before the break? Yeah. We won't have a look at it today because I really doubt that anybody did anything. Yeah. But I know this is natural. I gave it to you before the holiday because we all pretended we would look at it over the holiday. And then the holiday started and you realised, wait a second, I can catch up on my World of Warcraft. So, yeah. So this is why I'm giving you a few weeks now, because this way, as you work on it, you can see me about it, and I can help you through it. Okay? What's wrong, Leon? Great. Okay, so like I said, do you ask what World of Warcraft is? No. Yes. Okay, so like I said, we delayed starting the calculus part of the course until after the break, so we're on to page 60 now. Isn't it? I think so. Okay, so we're going to have a look at, go back to calculus. Right, so to recap, if y equals x squared, what's the derivative here? 2x, yeah, that's fine. And if y equals ex, its derivative? Yeah. So it seems like if we know the derivative of x squared and ex, we should be able to know what this derivative is. But in fact, we don't know what it is, because we don't have any rule for this situation. We can do problems like this, and we can do problems like this, but we can't do problems where these two are multiplied by together. So, if we go down a little bit here, you might guess, but you'll be wrong, that the derivative maybe it equals 2x times ex. But of course, if you said that, you would be wrong, because life and maths is never that easy, especially life. So, let me show you why it's not this. For example, if I have y equals x squared, I definitely know what the derivative is. It should be 2x. This is a definite fact we all know. Now, if I rewrote this as y equals x multiplied by x, and I tried to use my rule that I just imagined, that the derivative should be the derivative of each of them, what's the derivative here? It's 1, and the derivative here is 1. And we know that this is wrong, because it should be 2x, and this is not 2x. So, in other words, my point is, if we have f multiplied by g, its derivative is not as simple as f derivative multiplied by g derivative. It's not that simple. It's nearly that simple, but it's not as simple as that. So let's have a look at what the real rule is now. So this is just a little bit of motivation for what we're trying to get here, but now let's have a look at what the rule is. So we start off with, so you'll want to write this down, y equals f of x, g of x. Okay. So let's try and calculate this by using first principle method, where we have f of x plus h. If you want to actually make it a little bit clearer, you could say y of x is f of x, g of x. So you would have y x plus h minus yx over h. This is the derivative when we make h go to 0. So that would be f of x plus h, g of x plus h, minus f of x, g of x, all over h. This is first principle method, which you learned about in semester 1. Probably forgotten by now. Okay, so big fraction now. F of x plus h, g of x, gx plus h, and here gx fx. So I left a big space in the middle because I'm going to put something in the middle here that will help me simplify this. Now I can't just stick that in the middle because I feel like it. I have to at least balance it out by putting in the positive as well. So the two of them together these make 0. So now it's okay to stick that in the middle because together they cancel and they make 0. Now what was the purpose of doing that? Well, the purpose is now I have some way of simplifying, because if you look at the beginning, there's a gx plus h and a gx plus h. And if you look at the last two, there's an fx and there's an fx. So I can take these out as factors. So from the first pair, I can take out the gx plus h, and I'll stick it at the back. And then from the second pair, I'll take out the fx, and I'm left with gx plus h minus gx. And this is all over h. So each of them divide by h then. There's only one step left, and then we have the rule. So who can tell me, if I make h go to 0, what will this piece become if h goes to 0? And likewise, what will this piece become?
0.
No, not 0 and not 1. And not fx. And not gx. Not 0. No. Good guess though. No, nobody knows what this is when h goes to 0. Should look familiar. Yeah, what is it? Go on, I thought I heard you say it. It is the derivative. Do you remember, this is from semester 1. I said the derivative This seems familiar, doesn't it? It's when you make the h go to 0. This is the lesson called First Principles. You see, you're looking at this like, I've never seen that before, he's a crazy person. But you had a whole hour lesson on this in semester 1. And if you forgot it, that's fine, you need to check your notes. The lesson was called First Principles. Trust me, you didn't dream it, it did really happen. So this now becomes the derivative of f. And what does this piece become? That's just gx. And this is fx. And this is g, derivative x. So we've done it, we've made a formula here. This is it. So we can write it a little bit shorter. We can say, when y equals f multiplied by g, its derivative will be f derivative g plus fg derivative. This is the product rule.
Do we need the explanation for this?
No. I did it only for fun. Not your fun, my fun. Okay. Can we have a look at some examples now? So this is called the product rule. This is the product rule. Okay. Some of you have probably seen this before, if you've done calculus before. Not everybody, but I know some people maybe have seen this before. Yeah, some people have. But I understand that not everyone has. Let's have a look at an example. So let's take something simple like our x squared. We know what the answer should be. What should it be? It should be 2x. So let's try our product rule to see if we do get 2x. X squared is the same as x multiplied by x. So this is like f and this is like g. So what's the first part of the formula? F derivative.
X multiplied by 1.
Yeah, 1x. And then the next part of the formula is f multiplied by the derivative of g, which is also 1. This is f derivative g plus fg derivative. So 1x plus 1x, 2x, which is exactly what you thought the answer should be. So you can see that the product rule works in this example where we know what the answer is. This is only an example to show that it works. I used it on something where we know what the answer is, and we can see that we get the answer we know we should get. So let's use it for something where we don't know what the answer is. Can I scroll down? Yeah. So let's say something like what we had at the very start. X squared ex. So this is f and this is g. So the rule is, first we need f derivative g plus then we need fg derivative. So what's the derivative of f here? This is the f now. Yeah, the derivative of course is 2x and the g is ex and the f is x squared and the g derivative? Yeah. So this is it here. Let me give you one to try. Try this one for me. Try x cubed sine x. Okay, that should be enough time. They're not too long to do. So, you can kind of do these in your head. First we differentiate the first part. So what have we got there? 3x squared sine x. Yeah. And then we differentiate the second part, which is cos x with a plus. And that's the answer then. Yeah. Okay, let me give you something a little bit more difficult now to try. Triple. See if we can figure out how to deal with triple. Okay, how are we doing with triple? Some ideas, I hope. Yeah? So it's not too long to do once you figure out the idea, once you get the idea of what to do. It's not too different. So you have x squared ex sine x. You can break it up into two still. So you can have, this is the f and this is the g. So the rule is, differentiate the first one, keep the second one the same, plus keep the first one the same, and then differentiate the second one, which is ex here. Now this is fine, and this is fine, and this is fine, but then what happens here? Another product rule. So now the answer is differentiate the first one, second one stays the same, plus the first one, and then now this requires another product rule. So we have differentiate the first one, and then keep the second one, plus keep the first one, and differentiate the second one. Right, so after all that you'll get 2x ex sine x plus x squared ex sine x plus ex cos x. There's another way to do it. You might have had a guess at what the rule might be for triple. So if you have FGH, you might have guessed that the derivative should be f derivative gh plus fg derivative h plus fg h derivative. So you kind of get the sense that when you want to differentiate this, that the derivative runs across the top, hitting them one at a time as it moves from left to right. And that is right. That is how the derivative works. So in fact, it doesn't matter if you have four of them, FGHW, and you want the derivative, it runs across the top. F derivative GHW plus FG derivative HW plus FGH derivative W plus FGHW derivative. That is how the derivative works when you are multiplying. This is the product rule. Let's see if there's something trickier. I don't think there's anything else too tricky, but I do want to give you... Yeah. Try this one for me. Can I scroll down? Yeah. Okay, so I have y equals ex cos x. No, let's make it sin x. And I'll say x is between 0 and 2 pi. Find the maximum point. Okay, try this for me. Find where the maximum is. Do you remember how to do that? How do you find the maximum?
Second derivative.
Before that. What equals 0? Yeah, first derivative equals 0. Then you can check if it's a maximum by using the second derivative. Okay, got some answers? Let's have a look at it. You're looking a bit hopeless at the moment. Hopeless as in you've given up hope.
Is it quarter y or?
Sounds believable.
Minus 4.
Oh no, it can't be minus because I told you x must be
So
between 0 and 2 pi, yeah.
3 over 4.
Let's see. Right, so first we get the derivative. What rule do I need for the derivative? Well, the product rule. So that will be ex sine x plus ex cos x. And I want this to be 0. That's fine. So I have ex sine x plus cos x equals 0. Now, can ex ever be 0? No. So it's no point in considering this possibility. It's not a possibility. We're only left with one possibility. That's sine x plus cos x equals 0. This is the only possibility to look at. This is a little bit difficult to solve because it's a sine and a cos. Although there's a very nice trick here to simplify this. Any ideas?
You change it to how?
How?
You change like cosine to the...
Yeah, you can bring the cos to the right and then divide by the cos. And then as you said, this will be tan x equals minus 1. Now of course this only works if cos x is not 0, so right, so tan x equals minus 1. So that means x equals tan inverse minus 1. So in radiant mode, what do you get? I think you get minus pi over 2. No, pi over 4.
Yeah.
Or, and how do you get the second answer for tan?
2y minus 1?
No. not that one. That's for costs. How do you get?
180 is my.
That's it. Pi plus this answer. So this will be 3/4 pi. Yeah. Isn't it? Yeah. Yeah. Isn't that how you get the second answer? Yeah. You add pi. But there should be 2 answers in total. So I'm missing another answer. So this is the first answer. Now I don't reject this answer yet because remember the final step is the fixing step. So for the moment I keep these 2 answers. For the moment. You remember our process? Okay. So I'm at the making extra answers. So I'll make... Well, no, I suppose I have 2 answers, that's enough. I don't need to simplify, so now I need to fix, the fixing step. Is this answer acceptable? Yeah, it is. Is this answer acceptable? No. How can I fix it? Add 2 pi to this. So then we get, what's that? 7 over 4, thank you. 7 over 4 pi, or 3 over 4 pi. Now, which one do we choose? Well, that depends on which one is the maximum. Yeah. So we need to calculate the second derivative. So these are our possibilities for x. And what was my first derivative? It was ex sine x plus cos x, isn't it? Right, so let's calculate the second derivative. That would be ex sine x plus cos x plus ex cos x minus sine x. Now I don't have a calculator, so I don't know what will happen when you put the 2 answers in. But which one do we want, the positive or the negative? If we want the maximum, we want the negative, second derivative. So you need to put both answers in and then you need to tell me which one will be the negative one. Now, I can tell straight away that when you put these numbers into the part at the front, you'll get 0. And of course, well, I think before you go on, you can do this a much quicker way. When I put this in here, I know I'll get 0 because these values were the values of x that were supposed to make this 0. So I know automatically that this is 0. And I don't care about the ex because the ex is always positive. So which part is the part that makes the positive or the negative? It's this part here. So I only actually care about knowing if this is positive or negative. So for example, if this was positive, this is positive, and this is 0, the answer will be positive. If this was negative, this is still positive, and this is still 0. So what do I get altogether? I get negative. So you don't need to type the whole thing in on your calculator. You just need to check this part. Now you don't have to do that. This is just to save time. In fact, in the exam, maybe you shouldn't do that. Because, in the exam, maybe you think it's a great idea, but maybe you made a mistake, okay? But for class, that's fine. So can you put in this number in here, tell me what you get. Do you get a positive or a negative? Make sure you're in radian mode. Got your calculator? Did you get an answer, Tony? That's the negative. So when you put this in, you get a negative, and this must be then the... Oh, sorry, it's the other way. When you put this one in, you get a positive, so this one here must make a negative. So this one is the one we want. Now that's not quite finished, because what am I missing? Well, I said what is the maximum point, so I still need to find the y. No problem. I'll just put my x back in
EX.
to my formula here for y. And what is sine 3 pi over 4? Is it anything nice or is it ugly? Sine 3/4 pi? Ugly or nice?
Nice.
Yeah, what is it?
Root 2 over 2.
Root 2 over 2?
Yeah.
Great. I'll keep the e as an e. E 3/4 pi. This is the maximum. Radian mode, yeah. Yeah. Okay, did you write that down? Yeah. This question I picked was an exam question a long time ago, but it was still an exam question, 7 or 8 years ago. These questions are good for the final exam because number 1, it tests something from semester 1. Number 2, it tests something from semester 2. So there's 2 good reasons this would be a good final exam question, because it tests your knowledge from both semesters. You need to remember the derivative of ex and sin x and cos x. You need to remember that the derivative equals 0 for a maximum. You need to remember that for a maximum the second derivative should be negative. And you also need to remember that it's a product rule, which is what you learn in semester 2. So these are good exam questions because they cover topics from both semesters. So I see this, I'm imagining this as like a section B question, part of a section B question. Okay, let's have a look at what you have. Yeah, you can try these for a few minutes. Let's see how we're doing for time. Yeah, try these for a few minutes and see how many of them you can do. Hey, listen. Hey, remote. In the exam, it's okay if you write the answer down directly because you can do these in your head. For example, in question 1, a lot of them you can write the answer down directly, but some of them you need to do some simplifying first. Like for example, in C, what simplifying do you need to do first in 1C? I'll write it here for you. You have log x times 3 over e 3x. What do you need to simplify first? That's it. You need to bring the e up to make it a product. So this will be 3e minus 3x. Now you have a product. Okay? But like I said, most of these you can do in your head. If you want to write the answer directly, that's no problem. See how many of them you can do. You can do them for about nearly 10 minutes. Then we'll go on to the quotient rule next. So try these for 10 minutes. Yep. Where's yours? Didn't you go back to your room before the class started? What did you go back for? Your calculator? And the book is still sitting there, is it? Nice.